Hello everybody. This is our video solution to problem 5, the last video from quiz 3 here at Spring 2023 Math 302 at Cal State Fullerton. So let's see, the question gives us two subsets of a set U, right? So this will be sort of our universal set U. And without using De Morgan's law, we want to prove that R is equal to the intersection of the union of R of S with the union of R and the complement of S. Okay, and it's telling us the complement is, again, taken with respect to U. U is our universal set. All right, so if we were using De Morgan's law, we could probably do some good distributivity, and that would make this fall out pretty quickly. But we just want to do this by looking at elements. So the important thing here is I have two sets. Right? I have R on the left, and then I have this complicated intersection on the right. And if I want to show that two sets are equal, all right, so if I want to show A equals B, where these are sets, then I need to show that every element of A is an element of B. And then vice versa. Every element of B is an element of A, right? Essentially, this shows that A and B have the same elements. All right, so so here we're going to do our proof. Well, if I want to show that every element of R is in this set, then I need to choose an element of R, right? So let little r be an R. And I need to show that little r is in this set somewhere. Okay? Now, the important thing here is that once I know that little r is in big R, that tells me that little r, is in the union of big R and S, because what does it mean to be in the union? I have to be in at least one of them. Well, if I'm in R, then I'm certainly in at least one of R and S. So since R is in R, we have R is in R union S. But for the same reason, we also have that little r is in R union S complement. Once I know it's in R, it's going to be in R union anything. So, and R is in R union S complement. But if I'm in both of these sets, R union S and R union S complement, this implies that R is in the intersection of R union S and R union S complement. Okay, so we've actually shown that every element of the left-hand set is an element of the right-hand set. Now we'll go the other way around. Now let's well, I don't want to use little r the same way. It might be confusing, so let's call it something like x. And let's let it be in the intersection of R union S with R union S complement. Okay, so if I'm in this intersection, that means that I'm in both of these two sets, R union S and R union S complement. So this implies X is in R union S and X is in R union S complement. Okay, now, if I'm in R union S, that means I have to be in R or I have to be in S. So let's look at these two situations. Okay, so in this first one, right, so this implies X is in R or X is in S. Now, if X is in R, we're done, because that's the goal. We wanted to show that every element in this intersection was in R. So if I have an element X and it's in R, then I feel pretty good about myself. Well, what if X is in S? If X is in S, then we know that X is not in the complement of S. You cannot be in both a set and its complement. Okay, but if X is not in the complement of S, now we go down here and look at this. We know that X is in R or X is in S complement. And we just said it's not in S complement. So this would imply, right, using this statement, that X is in R. So in either case, either X is in R and we're done, or X is in S, which will also imply that X is in R and we're done. And there we go. So this actually does the proof right here.